Okay, so let's say that this would be a kind of exam problem that I could see. Write verilog code that let's see. Creates a 4-to-1 multiplexer with the following behavior. If S equals 0, 0, output is X 0. If S equals 0, 1, output is X1, X2, output is X3. Name your module four to one S X Q. Okay, and then part 2, use that module to create a 3-bit shift register. Let's do 3-bit rotate right register. Okay, so let's say this seems like, you know, sort of a question that they might ask. All right, so so the first thing we want to do is to create that code for the 4-to-1 multiplexer. So we'd have module 4-to-1 S X Q, and then we would have input S, input 0:1 S, input 0:3 X, output 0, or just output Q. Okay, so then And, actually, I'm just, for whatever reason, I'm just not going to use an always block this time. Because it's not a flip-flop, and because since it's not a flip-flop, I don't care about the when, so it can just happen at any time. So I'm just going to have case S 0 colon begin 0 colon Q equals. Actually, can I do this? I don't know. I'll be safe. Q equals X 0 1 Q equals X 1 2 Q equals X 2 and 3 Q equals X 3 and end module. Okay, so that's all there is to that one. So now I want to use that module to create a 3-bit rotate right. So I want to think about how this is going to work. And I can call this mux 1, mux 2, mux 3, D0, D1, D2. Alright, so module rotate right. And my inputs would be S, X, and output is D. So input (0, 1 S). Output, now this time I do have flip-flops in there, and so I am going to want these to be reg. So reg 0 colon 2 D, and I'll have a wire, which I will also, actually I can just call it reg. I don't need to put wire. Reg 0 colon 2 Q. Alright, and then now always at, oh, I also needed a clock. Always at S, X. Okay, so let's see. What do we want to happen here? So we need to have, I'm going to instantiate 3 copies of actually I don't know that I need this always block. We'll see. So I'm going to put in 3 copies of my multiplexer. So I'm going to have, and I'm going to name them just because it's going to help me remember how they work. So 4 to 1. Let me make sure I've got my syntax right here. Okay, 4 to 1. I'll call it mux1. And then, so this one would have as its input, I need S, comma, X. Let's see, what's its input going to be? We're rotating right. Okay, so we have 0, 1, 2, 3. 0, 1, 2, 3. So this first one would have as its input so I needed more information in my description to create a 3-bit rotate right register, and I'm just going to put, this is going to be, so it won't do everything. We'll just say when S equals 0, 0. Okay, so so when S is 0, 0, then we would want in its 0 input, we would have D of 2. Well, we just put D. No. I have to think about this a little bit. Give me just a second. Hold on. What the answer will be, because right now my brain is, I'm too nervous because I feel like, oh no, I've messed up and now I can't think. So I want I would, whatever I input, so, okay, what I would do, so I didn't specify all the different possibilities for S. So, if I specified all the different possibilities for S, so like let's say that if S is 0, it rotates right. And then else it stays the same. Okay, so not a very interesting one. Then in that case, then what I would want to happen is for my first multiplexer, I would want my input value here, all I would want is I would want to make my input, let's see, how am I going to put this? Q of, I'll do it like this. There we go. Rotate right. Okay. There we go. Now I got it. Okay. So on this first multiplexer, what it has is if S is 0, it's going to have as its input D2, which is this last one. Otherwise, for all of our other inputs, I guess I needed one more input there. For all of our other inputs, no, it's just 3. Well, except I have 4 possibilities even though it's a 3-bit multiplexer. So for all of my other possibilities, I'm just going to have D0, so it's going to stay the same, and then my output is going to be Q0. And then for my second multiplexer, 4 to 1, mux 2, input S, what it's going to have is, so we're rotating right, so what it's going to have for its in its 0 input is going to be D1. I called it, why did I call it 1? Well, I called them 1, 2, 3 instead of 0, 1, 2, but let me change the 0, 1, 2. So, and then for the others to remain the same, it needs to be D1. And then its output would be Q1. And then for our last multiplexer, its input is going to be, for the 0 port, is going to be D1, and then all of its others should remain D2. And its output will be Q2. So then we made those multiplexers, and then we'll have an always block. So always at positive edge clock. D becomes Q. And module. So sorry that took me so long, but the idea here, so this is the idea of what you would need to do. So you've got this other module that you need to use in some sort of way, and the way that we're using it is we're saying rather than having a case statement to say what happens in each case, we're using the multiplexer to do that. And so what the multiplexer is doing is saying if S is 0, that's going to be what the output is for the 0 for from the 0 terminal is going to be, or the 0 input is going to be that. And then for the rest of them, I didn't have it do anything other than stay the same, but I could have had something different for each of those different values for what our output was going to be. So that's an idea of what you might have to do. Other questions?